Hello. If you're looking at this video, it means that my internet connection is extremely terrible, and I'm so sorry about it. My name is Anton, and I'm helping a different company with some architectural issues, and that's why I can use this image without any problems. And also, maybe you know me as a guy who joining any conversation about Hanami, and also I'm core member of Hanami and RubyConfBY project. If you want to talk with me, you can use different topics like memes, JRPG, Kendo, beer, coffee, Nintendo Switch, or how to draw some images. And let's start with Inception. Usually when I have a conversation with the different developers, I ask them about how they understand the project, and usually they answer me that they just read the code. And it's really a strange situation for me because we have a visualization, and today we will talk about visualization. If you open Wikipedia, you'll see that visualization is a technique for creating images, diagrams, or animations to communicate a message. And as a general idea why you need to do it, it's because visualization allows you an effective way to communicate some ideas to other people. And you can agree that visualization is great for data because instead of checking some numbers or integers, you can just read a diagram or chart or something like this, and you can understand it much better rather than calculate everything in your head. Also, visualization is extremely great for complex systems. For example, a few months ago, I built a blog platform in 2.5 hours. I use SQRS and Kafka with 3 different services, and if we will check the source code, you will spend more time rather than just check this diagram to understand what happened in my source code. Also, visualization is a great idea for database visualization because you can just easily see what the association between different tables, what exactly you have in a specific table, and etc. etc. But what about a source code? Based on my experience, I have 2 different types of visualization if we are talking about source code. The first one is execution call. What I mean, if you open a Ruby visualizer in your web browser, you'll see a window with your source code. In my case, it's a merge source. And also you'll see that you can go back and go next or back to some steps, and each step is one execution step of your compiler. And for example, you can go to a specific step, and you will see that you have a different values in a different stacks in Ruby compiler. And you can go to the last step and see what will happen. And this visualization is extremely useful for understanding how compilers work. And for example, I want to recommend you check this blog post from Ken. It's a blog post where a guy visualized the garbage collector algorithms. If I remember right, he had 5 different algorithms with GIF animations, how it works, and it's extremely useful to understand. But it's extremely low-level visualization, and I think it's not useful for real work or with real applications with Rails. And for example, I want to show you how I tried to visualize execution call for my small library. I had an extremely small library. It's just a calculator based on back Polish notation. And as you can see, I just create a new instance of calculator, call it with a string of some specific string, and got a result. And if I put everything into one source file, I'll got around 1.5 lines of code. You can use this link to Git.io. You will open a Git with a full source file, and I put everything into my Ruby visualizer, and going to a specific step on the last, it was one of the last steps, I got 2 feelings. First of all, I was surprised that it's just 1.5 lines of code, and I can't understand everything. And my second reaction was, what is happening here? Because really, I can't understand what exactly my code do, because I need to go through each step, and based on this information, I need to download or put everything which compiler do into my head. But basically, what I want to see in my source code, I want to see something like this. I want to see that string go to IST parser. After that, it's go to write Polish notation executor, get some tokens, and this token go to specific converter, and after that, I can take a result. And I surprised that if we open some specific, if we are talking about visualization, we can talk about execution flow visualization. But if we're talking about a full project visualization, usually we try to imagine some dependencies between code, for example, and on dependencies, we want to see what exactly these black boxes will potentially call for specific execution. And it's a high-level visualization for us, and we can easily put a full application into one image and just easily understand it and work with the source code. For example, we can use my diagram with 3 different services: block, platform, system, and SQRS. And for example, you can see that if I want to save some users, I'll call write API command, as this command will go to specific command, after that to the write repository, and after that information will go to read or write database, and also I'll create a new message in the Kafka on specific topic. I found a really interesting project based on Erlang or Elixir. If you open this GitHub link, you will see something like this. It's animated images, but in my case, it's just a static image. But based on this project, you can visualize everything in your Erlang virtual machine. And you can visualize each actor, you can group it and see how it works and what happened in your system in real time. But also I have one more visualization. It's imagination visualization based on Hanami visualization. And for example, I have a source code. Don't worry if you don't see it. It's just action with some specific calls for operations. And on visualization of this project, I want to see something like this. I want to see that I have an action with the name of this action. I want to see that this action calls specific operations. In my case, it's 2 different operations. And for example, if I call operation for put some services, I'll also call a repository worker and some core dependency as a role bar. If I'll call a different operation, I'll call organization repository and also role bar if I have some issues or errors. But why we can't cover source code to something like this? And I have a crazy theory about it. And this theory is about we have some raw data, it's a code, and we want to visualize it. We want to make a visualization, but to make this visualization, we need to transform our raw data to something, and we need to add some meta information to our code. And usually, we as developers, we add meta information to our code in our imagination. Because when we check some source code, we can easily say, oh, it's a repository. Repository is about storing or getting something from database. And that's why only humans can draw something useful, because we have this meta information about our source code or something like this. My biggest idea is how to do it automatically and how to say that computers should work for me and generate some visualization of my source code for myself. And let's talk about Ruby. If we're talking about Ruby, we need to start with a simple question, and the question is what exactly we want to visualize. I have 5 different types of data visualization for the projects. The first one is a code execution. We talked about it a few minutes ago. It's really useful for understanding how compiler execute code. And if we remember, if we are talking about more than 1.5 lines of code, we get some issues. And it's a really great idea for learning proposed, but extremely low level for production and for real and huge applications. And if we're talking about learning, check any presentations from Aaron. He's using visualization for explaining how Ruby works, and it's really cool and useful for everyone. But if we will try to visualize how Ruby works with a huge Rails monolith application, we will break our mind, I think, or it will be extremely terrible for us. The next visualization is libraries or gems. If you want to visualize dependencies, library dependencies, you can easily use a command which is called bundler with. It depends on Graphis library, and I have a project based on Hanami, and I call this library. It's a small project, and I call this command in my command line and got image like this. It's extremely huge, and I think you don't see anything here. But if you will zoom in, if you will zoom it, you will see that it's extremely terrible to understand what exactly happened and how all these connections going through the diagram and what exactly have. And it's extremely complicated to say what exactly we have here and what exactly we need to do with this information. And it's really great for bundler. It's really great for developers who work with a bundler. It's really great for developers who want to drop some libraries or see what happens if we will update some specific library. But I still think that it's not super useful for real developers who work with a business code. That's why the next visualization in our code, it can be a business flow. And if we want to talk about business flow, I want to invite my friend Nick. And if you don't know, Nick is the author of Trailblazer library. And if you open a trailblazer.com, if I remember right, you will see a really nice tool for visualize and working with BPM. BPM, it's a visualization for business processes. And if you zoom in, you will see that we have some business flow, and we have specific steps, and each step can go to a specific way, and it can be not found, successful, not authorized, or something like this. And it's extremely great for business and for understanding the business flow, but unfortunately we can't visualize a full system, because if we go to this diagram, it's extremely complicated to say what we will call in a domain activity. We will call some libraries like Redis, maybe Sidekick. Will we do something like this or not? And it's extremely complicated to say what will happen here. The next visualization is a visualization of Ruby classes, and we have a project for this, and it's called like Ruby browser, like a browser for Ruby. And I tried to call this library with my small project on Hanami. It's called Ruby jobs, and I just call this line in my command line interface, and I got something like this. Again, it's not useful for understand what happened here, but if we will zoom it, you will see that we have different classes, and we can see that all inheritance in our classes is edges between nodes, and each node it's a class, it's a Ruby class. But in real code, I have a dependency call between web controller review, because it's my action, and review operation list, because it's operation which I call in my action. And I want to see something. I want to see associations like this in my source code. And this library is extremely good solution for work with the classes and class inheritance as a direction for dependencies. But it's impossible to detect what I exactly call for my action or for my service, because usually I don't want to see how my classes inherit on each other. I want to see what exactly happened if I'll call a specific action in my application. And it's really hard to understand where I'll call redis.new or where I'll call Sidekick or something like this. And that's why let's go to the last type of visualization for Ruby code. It's dependencies. On dependencies, I mean isolated part of source code. And for example, we can go to repository discourse /discourse, and in this repository you can see an action which called username. And in username, let's try to understand how many dependencies we have in this action and how many dependencies call we have in this action. The first dependency which you can detect, it's a user changer. It's something like a service object, and we call it for change a user with a username, with a current user and we want to change a username. The next dependency which I see, it's Guardian, because we need to check can we edit a username for specific user. And the next one, if we'll go to a method which call render JSON error, you will see that we also call a specific dependency which call a multi-JSON to dump our data into JSON. And based on this information, we can say that this action calls 3 different dependencies in a code. And I want to see something like this. I want to see a graph, and I want to see that my action username call specific dependency like a Guardian, and after that it's a changer class, and after that it's multi-JSON object. And based on this information, I can say that username action checks something for change a username, after that call specific changer class, and after that using a multi-JSON to dump data to specific format. And and based on this, I start thinking how we can detect calls in dependencies, how we can detect what exactly we need to call for specific action, for specific service, and etc., etc. And the answer is an invention of control container. And it's an answer only for me, and let's talk about it. I'll explain why this answer is only for me. First of all, invention of control container is just an object or something else. If we're talking about Ruby, it's an object which you know about project dependencies. And usually we have a container. This container manages lifetime of objects, and we can call a registry. We can register something into this container, and after that we can take some dependency from this container. And I draw a specific images for explain my idea better. For example, we have a container and we register some dependencies into this container. And also we know that if we want to build a dependency 1, we also need to use dependency 2 and dependency number 3. And also if we want to build the last dependency is dependency number 4, we need to use a dependency 1 as a dependent dependency, and also we need to use dependency number 2. And if we will transform all this information to something else, you will see that we have a dependency 4, dependency 2, dependency 1, and dependency number 3. And all this data can be transformed to the graph. And because we have a graph, we can start working with it. And if we are using a container, we can say that our dependencies in the container is our nodes. Each injection between dependencies, because all dependencies in our container we can easily detect it, each injection will be H. And if we'll go back to my simple image, each dependency is a specific node, and each injection of a specific dependency into a specific dependency again, it's an H, and we can imagine this invention of control container as a graph, and based on this information we can easily visualize it. And let's talk about my theory and the biggest problem which I found to work with this idea. I told that for make a visualization something, we need to take raw data. In our case, it's a source code. We need to transform to this source code to something and add meta information. And for example, today we're talking about visualization, but we can't visualize something if we don't transform the raw data to something. And in my case, we can't visualize something if we will not add meta information to our code. And what I mean in my case, talking about meta information, for example, I have a repository class, and it's just a repository class. I know it from the name, and I know that repository is something which works with a database. But if we're talking about a code, it's impossible to say what kind of dependency we have in our invention of control container, and we can't detect how exactly we need to visualize this dependency in our graph. And we know. Again, we know that repository related to we know that repository is something about persistence logic, but our tools which we use to visualize something and our idea about this tool have zero idea what exactly we have in a repository, because we don't have any meta information which call our tool that repository is something about persistence layer. And we need a solution to provide meta information about the code into this tool. And I think the biggest problem in a visualization of Ruby code, it's about how to add some specific meta information about the code and how to use it in specific tools which will collect Ruby code, transform it to something, maybe detect some specific cases, and after that visualize it. And let's go back to visualization. I talked about invention of control container, and if you know, dry system, it's a solution which provides you invention of control container. And if you open documentation, you will see that we have a container, and it's main container where we can call registry logic for register specific dependency, and this dependency have a key. It's usually a key which we use for take and access to this dependency, and also we have an object which we need to use as a dependency. If you go back to documentation, you will see that dry system also provide after inject logic to work with injection to specific class, and we have a injector method which converts our container into specific injectable object, and after that we can easily call this injectable object to inject a dependency into our class. And it's some specific sugar for dry system, because this line of code transform into a class constructor with one argument, it's a logger, and as a default value of this argument, it's some object which we can take from a container using this key. And right now, if we are looking on dry system, we have absolutely all information for generating graph and dependencies. And I built a library which called dry system dependency graph. Right now, it's a proof of concept, and generally, I have no idea what I'm doing with this library right now. And the general idea of this library is something like a sidecar for dry system. And in this sidecar, I can collect dependency registrations and injections in one place. And based on this information, I can easily generate a graph of all my dependency in my system. And I'm working on this last more than 1.5 years, because I created this. It's a first pull request with this functionality, and as you can see, I created this pull request more than 2 years ago, and also I thought about this idea more than 1.5 years, and how I can build a graph for dry system container. I can I have 2 different versions of this library, and in a version 1 I used a graphics library to visualize something, and the general API was you have a file where you can register your container into dry system dependency graph object. After that, you need to finalize your container. It's default dry system logic, and if you are using dry system, you use this finalize call every time in any project. After that, you can use an optional step. In this step, you have a container, and you can easily map a specific web application, like in a sidekick, to a specific endpoint into your rec application. And based on this, you can start your rec application, go to endpoint, and when you go to endpoint, on my first version, you'll see something like this. And it's a real code. I did nothing to generate this library, generate this diagram. I mean that I just built a dry system application, and after that I just call my library, and it's what I get after executing my library. You can see that I have some dependencies in a service scope, and I have a scoped box for all my dependencies in a services key, and you can see it here. Also, you can see that I have a service which called other service, and if I'll go to source code of the service, you'll see that I have 3 different injections. It's a service empty service, it's a repository, like a comment repository, and it's a post repository dependency, which I inject into my service object. And on my diagram, you can see that all these dependencies you can see all these injected dependencies in a specific positions, and also you can see that I have a post repository, and this post repository also depend on persistence.db key. And the most interesting stuff here, I can use alias for my dependencies, and instead of post repo, I will call my dependency just a repo. And in my diagram, I have 2 different dependencies. It's a service and injected dependency with a repository, and also you can see that the name of my injection is a repo, and I can see it on the edge. So also I can detect recursion dependencies on the first version, and what is it? It's, for example, we have a dependency A, and we inject dependency B into dependency A, and in dependency B we also have a dependency A as an injected dependency. And based on this logic, we have a recursion, because dependency A inject dependency B, and dependency B inject dependency A, and etc., etc. And I can easily detect it based on my library. Also, I had a heatmap for dependency call. What is it? In my example, I had a entry point like service call, and in a service call, I just call a specific service. It's other service, and I just call it without any arguments. And when I call it a few times, you'll see that the color of this dependency will be a little bit different. And when I call it 6 times and hover to my dependency, you'll see that I can calculate how many times I call specific dependency, and all nested dependency for the dependency. And I was extremely happy about it, and I started to work on second version. And the general idea of the second version, it's a current version for current moment. I wanted to make it dynamic. And also I found a project, it's a real project. If you attended a Ruby conference in St. Petersburg in the previous year, maybe you remember that we had a Telegram bot, and in this bot you can calculate how many beers you drink on a conference, and also you can send a head into a stage where and everyone can see it on a speaker presentation. And I just use this bot because this bot was built on dry system, and when I start using it for my library, I got something like this. Right now I used a different library. It's a JavaScript library, and it means that you can easily move any dependency to a specific place and see how to communicate and how it depend on each other. Also, I added a grouping functionality. What does it mean? For example, I had some scopes. It's like blue boxes, and you can easily toggle it into one small box and see that, for example, all my commands depend on services. I don't know what kind of service they need to use, but I can see that I have one command which depends on services and also for repository. My favorite feature for dry system dependency graph right now, it's a source code for nodes. I steal this functionality from Pry project, and for example, if you click on a specific dependency, in my case it's a task repository, you will see a source code for this dependency, and you can browse source code for specific dependency in real time based on this diagram. And it works not only with source code in your project, it also works with source code from dependencies. For example, in this slide, I opened ROM container source code because I had a ROM as a dependency for my repositories, and I can easily check how it works, and I can easily navigate in source code and see what happened here. Also, I still have a alias naming for injections, and let's talk about future. In the future, I have some ideas how I can improve it, and the first idea is start working with the meta information for dependencies and injections. Because, for example, based on this meta information, I can create some deprecated dependencies, I can create dependency type, and based on dependency type, I can allow or delete some injection. For example, I can say that in my project, we can't inject a repository into action, and based on dependency type, I can easily do it. And also, we can add some domain information, and based on this, we can easily detect and also prevent some injection from one domain to other domain. For example, we want to call service object from one domain in other domain. Based on meta information, we can easily and automatically disable this functionality and raise a error on the start of your application when you inject something wrong into a specific place. The next feature which I want to implement in the next releases is layers, and in layers I have some ideas in my head, and for example, I can create a specific layer for Git status. And what does it mean? For example, I have my dependencies, and I worked only with one dependency. I have some changes in the source code of this dependency, and it means that I can easily detect what kind of dependencies I also need to test. And also I can easily detect what kind of flows or dependencies I need to test in my test suite. And based on this information, I can easily create a regression test framework because I know changed dependencies. I have a graph of all dependencies in my system, and I can easily test only all dependencies which depend on my changed dependency. The next layer is spec coverage. For example, we have some dependencies, and I know that on a red box I have a low test coverage, but in a green box I have extremely high test coverage. And based on this information, I can easily detect what kind of dependencies I need to test, or maybe I can understand that, okay, if I have a great test coverage in a green box, it means that I can forget on some time for increasing test coverage for red box. The next layer which I have in my imagination is code owners, and what does it mean? It's just an idea for maintaining really huge projects. For example, I have dependencies, and also I know that I have 2 different teams, and these teams own 3 different dependencies. And for example, I have a yellow team and blue team, and I see that both teams own only one dependency together. And based on this information, I can say, oh, it's something strange. And also, I can see that in my image, I have one dependency without any code owners, and it's a danger dependency for me. And based on this graph information, I can easily detect what kind of dependency I need to assign to a specific team. And also, I want to make it custom, because I understand that a lot of people can create more interesting ideas, and that's why I want to make these layers absolutely custom, like middlewares for Sidekick or something like this. And based on this, everyone can create a specific layer for specific purpose. The next feature step, it's depend on my different project. I have a project which called Inventarium. It's an inventory application for microservices, where you can describe something in a YAML file and easily search a specific service, check a status of the service, what kind of information you need to add. Maybe you need to add a CI or CD. And also this project can easily visualize different services, and also visualize some message brokers. In my case, it's a Kafka. It's still work in progress. It's a proof of concept project. That's why UI design is not as super cool. But the general idea, just imagine that, for example, you have a accounting service, And by clicking on account service, you can open all information based on dependencies in this service. And based on this, you can easily detect what kind of dependencies you have in a specific service, and etc. etc. And also, migrating on the second version, on the current version of dependency graph library, I broke a heatmap, and I really want to fix this functionality because it's really useful for me. Because if I'll start this library in production and collect information about dependency calls in one day, for example, I can easily detect unused dependencies, unused code in my library, in my project, and easily remove it. And based on this, I can reduce the count of lines of code in my project without any problems. And I have a visualization to everyone, because if someone's asking me why I want to delete something, I can just easily show them that, hey, sorry, we don't use this dependency one day, and that's why we can easily drop it. And some conclusions about my talk. The first thing, visualization. Unfortunately, visualization is the last step in the data processing. And before start working with the visualization of code, we need to start understanding what kind of data we want to visualize. And unfortunately, we have only one abstraction for getting dependencies and injections for Rails code. It's really a best situation for Ruby ecosystem because we don't have something in Rails, we don't have something in a Hanami 1.0, for example, but in a 2.0 we will have integration with dry system, and that's why we can easily use my library, for example, out from box in a Hanami 2.0. But right now, again, we don't have anything. We don't have any abstractions for getting meta information about dependencies and injections in our code. And also, we don't have zero abstractions for meta information about our dependencies or about our injections. And it's extremely complicated to say what kind of dependency we have right now. Is it a client? Is it a model? Is it something else? And only our brain can find the answer on this question. And of course, you have two options. You can use a dry system, and you can play with my library, or you can try to make something different for getting data and metadata for visualization. I mean, this idea, it's extremely simple, and using only one invention of control container, you can easily create an extremely crazy tool for helping yourself or a full team to understand and work better with your project. And it's not a dry system or dry in general it's not only feature for dry or dry system. You can easily build something else in your source code and try to work with it. And but unfortunately, I see it only with a dry system container right now because it's only one abstraction which I can easily use right now. And again, if you want to play with my library, go to GitHub repository. And thank you, everyone.